Hey guys, how's it going today? Today we're going to start our unit on the behavior of gases and gas laws. Gases are one of the four major states of matter we see in chemistry, but they can often be a little more difficult to work with than solids, liquids, or dissolved materials. In this unit, we'll look at the properties of gases and the way we measure and use gases in chemistry. For today, we're going to start by taking a quick moment to review what gases are and some of the basic properties they have. Then we'll learn about the kinetic theory of gases, and finally, we'll start touching on the major properties of gases we want to look at throughout this unit. Earlier in the year, we defined gases as a matter in a state that has no constant shape or volume. Gases take on the shape of whatever container they are placed in, and they fill the entire space of the container they are placed in. As I'm sure you've discovered throughout your lifetime, gases are less dense than liquids or solids. This is why you can move through the air around you with relative ease. Swimming in water is a bit more difficult, and if you try to move through solid ground, you won't have a great time. Gases are also usually composed of single elements or covalent compounds. The noble gases are all single, unbonded, free elements that remain in a gaseous state. Oxygen, hydrogen, and nitrogen in the atmosphere form a diatomic compound, which means that each atom pairs with another atom of the same kind. So one oxygen will bond to another oxygen to form O2, one nitrogen will bond to another nitrogen to form N2, and so on and so forth. These are all covalent compounds. Because of their high melting and boiling points, ionic compounds are found in the gaseous state less often than covalent compounds. Most gases, if cooled enough, will condense into their liquid or solid state, though some have boiling points far into the negative temperature range, which is why we don't see a lot of liquid O2, for instance. Carbon dioxide, which is generally a gas at room temperature, can be cooled into a solid, which we commonly call dry ice. Nitrogen also tends to be a gas at room temperature, and when cooled to a liquid, it is so cold that it can instantaneously freeze objects it comes into contact with, and that's what you probably know of as liquid nitrogen. Now let's look at the kinetic theory of gases. The kinetic theory of gases is really more of a model than a theory, but it describes the behavior of gas particles and their motion relative to their other properties. The basis for the theory is the idea that every gas particle is constantly moving in random directions. Particles bump into and deflect off of one another. The speed at which the particles move is dependent on temperature. Particles hitting the walls of a container is what causes pressure. Pressure and temperature are two of the four major properties of gases that we want to focus on when working with gases in a chemistry lab, along with volume and the number of particles, which can also be measured as mass, as the two are closely related. The kinetic theory of gases can help us make some predictions about how these properties interact. Let's take a look at some examples. On the right here, we see a cubic container filled with gas particles. The gas particles are represented by the pink dots, and their velocities are shown with arrows pointing in random directions. Now, if we keep the dimensions of the cube the same, as well as the temperature, but add in more particles of gas, do you think the pressure will increase, decrease, or stay the same? Remember that the kinetic theory of gases tells us that pressure is a result of gas particles colliding with the sides of the container they are in. Because of this, adding more gas should result in more collisions with the side of the container, so the pressure would increase. The reverse is true as well. If we decrease the number of particles in the container, we would see fewer collisions with the walls of the container and the pressure would decrease. Another variable we can look at is temperature. Now, let's say we keep the dimensions of the cube the same, but instead of increasing the number of particles, we increase the temperature. Do you think the pressure will go up or down? According to the kinetic theory, temperature increases the speed at which gas particles move. Increasing the speed should increase the number of collisions with the container walls, so the pressure will increase as the temperature increases. The reverse of this is also true. If we decrease the temperature, the particles will move slower and the pressure will decrease. The last variable we want to look at is volume. Remember, the gases take on the volume of whatever container they are placed in. So, if we increase the size of the container, but keep the temperature and number of gas particles constant, will the pressure increase or decrease? Increasing the size of the container means there is more room for the particles to move before they hit the edges of the container. This means there will be fewer collisions with the walls of the container, resulting in a lower pressure. So we can predict that as volume increases, the pressure decreases. And, as in other properties, the reverse is also true. If we put the same amount of gas at the same temperature into a smaller container, the pressure will increase. That's all the new material we've got for today, so let's take a moment to review. We know that gases are one of the four major states of matter that we look at in chemistry. We also know that gases do not have a constant shape or volume. They take on both the shape and size of whatever container they are placed in. We learned about the four major properties we are concerned with when dealing with gases, which are temperature, pressure, volume, and the amount of gas, which can be measured in mass or in number of particles. Lastly, we learned about the kinetic theory of gases, which describes gas particles as constantly moving and states that increasing temperature increases the speed of that movement, and that pressure is caused by gas particles colliding with the sides of the container they are contained in. We also use the kinetic theory to describe some of the basic relationships between properties of gases, like temperature and pressure and volume and pressure. Next time, we'll start looking at some of the laws that govern these relationships, but that's it for today. Thanks for watching, and I'll see you next time.